All right, let's do take two of this. The previous version, when I got to the exponent portion, I could not figure out how many parentheses I needed. Wonderful, wonderful, wonderful. And I was just off one. I'll show you now how I fixed it. So what we're doing, we've got volume, we've got effective area, we've added coefficients, we figured out Sabins, summed the Sabins, done some averages so we know where we are in the realm, and now we've calculated reverberation time with Arian and Sabin equations. Now we want to set targets so we can backwork that and figure out where we need to add absorption, where we should take off absorption to get uniform distribution of absorption and to make a flat room is the goal in this case. So we're going to look at 1.2 seconds. So let's set the target. Let's do a new section, call it targets. RT60, and that's in seconds. And we'll set that at 1.2. Gonna go all the way across. This is a 1.2 room. We've decided for no other reason than we like 1.2. Let's do the earring absorption. I said that in the previous one. Be an average here, and then we'll figure out the absorption there. So we're doing earring because it's the most complicated one in this scenario. We could also do the Sabin and swap RT60 with absorption to figure out what we need. But in this case, we've got to do a inverse of a natural log, which is an exponent. And since this is not a math class, I'm just going to give it to you so you know it. So let's start with equal. Wrong tab. Let's do equal. And we're going to do 1 minus 2 exponent. 2. So we'll do exponent within this whole number. Everything after that, we need the section of 0.049. That should be pretty familiar in times. We're going to do that. We're going to do volume. Grab the volume. Absolute that so we can copy it. Close that parentheses. Do a divide. Negative the surface. Absolute that because we'll copy it. Ooh, I almost forgot my parenthesis. Let's do a parenthesis minus times what our goal is, our RT calc goal, because 3.49. Close that. And before, what I didn't have was this parenthesis and that parenthesis, and it's giving me create it. So see that. Give me the number. Not know that I want to look at the entire number. Do that. So 0.34, we're at 0.15. So we basically need to double. We double absorption in the room. We're going to go from 3.2 to 1.2. So let's change that number. We don't need to be that precise. 10th of a second is fine. Copy that across there. If we change this to 1, we need a 0.4 room. If we change this to 3.2, we need a 0.5 room, which matches what we have up here. So we are good. Well, that formula works. So now we're going to figure out total absorption. Let's do some averages. So if we equal average of this, it'll be pretty straightforward. They're all the same, but You may dial this in a little bit different. If you wanted a warmer room, change this to 1.4. 0.4. Didn't want such a bright room, change this to 1.2 or 1.0, something like that. But let's keep it 1.2 for now for simplicity. Let's take that out to the hundredths. Center that. Got the now we've got average. And figure out total. Total absorption, which is just this times so our absorption average times our surface, total surface. So that's how much absorption we should have in the room. We want if we want a 1.2 room, we have 4,000, so we need a little bit more than double in there. But instead of guessing what that is, approximating, let's do needed absorption. Move that over. That's will equal this total minus what we have existing. Let's put units on there. Center that. If you're fancy, you can do a conditional formatting here that if it was positive, it turns green. If it's negative, it turns red. I'm just going to color it muted yellow. So we've got the targets. We've got our needed coefficients. We have our existing coefficients here. From up here. And one thing we didn't back out is what the average coefficient across this whole area is. And that's as simple as taking that total absorption summed here, dividing it by that total area, F4 that, copy that across. I'll show you a little shortcut here. If you take that off absolute, hitting F4s, we can copy it down, then make it back to F4. Let's get around that to the 100th. So Control C, Control V, Control V, Control V. Now come back up here. C13 is the area. No, it's not. I did that wrong because I copied it down. So C19, let's go back and fix that. C19, 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 C19. So we got C19. This one should be C25. Winner, winner. Chicken dinner. Guess it wouldn't be a winner if you're vegan or vegetarian. But tofurkey? Tofurkey? Winner, winner. Tofurkey dinner. Sort of rhymes. Never claimed to be Bob Dylan. Or Lil Wayne. Those two are comparable. Yes. Wayne and Dylan. I don't know how many times you'll hear that in a I'm just copying these and rambling for entertainment purposes only. So we've got that. Now we've got that average absorption. Now we can break out what we need for goals. So now we need to do ceiling, or we need to do areas, needed coefficients, and then needed area. So if we take equal up here to ceiling, we change that up there. We don't have to change it down here. Only type once. So needed. See if I can spell coefficients. Right. Needed coefficients, needed area. Edit area. Needed area. Yes. Got it. So for needed coefficient, we're going to subtract from this what we have existing. So if it's positive, we'll do an equal. We need 0.34 for the ceiling, and we have 0.15. And we'll copy that over. We don't have to absolute those because they're in parallel. So that's the needed absorption that we need. So we need to add 0.15. I don't like that being needed area. So the needed absorption that we have is equal to that coefficient times ceiling area. Do it that way then. So we need that many more Sabins at this octave band. F4. So we need 750 Sabins. Add units on that. So if we know that we have a 2x4 panel, so 8 square feet, and if it's got a 0.5 absorption, we know that's 4 Sabins, 4 into 7. 200. 187 square feet of panels. That by 8. So we needed approximately 23 panels on the ceiling. So that's good. What we need. So we've got that absolute. We just need to multiply it till for our needed absorption. So as you can see, if we did the same amount of panels for 63 and 125, we're going to be over in 4K. So that's what we want to look at to make this room flat in there, to give us an idea of how much absorption by Sabins. So we've got ceiling. Let's do, I don't like that at all. Horrible scrolling. Go wall east. Copy that down. Do the next surface. This is where we're getting to a big sheet. So we did north wall, we will west wall. Copy. All copy. So we did west wall. Should be south wall. Wall. So I'll do the panel example for something that's not the ceiling. So we could hang 24 panels up there, 27 panels. So I control Z my way out of something. I did. That's incorrect. Let's take this minus ceiling minus what we have. So our needed, that makes a little bit of sense. Got to see the mistakes so you can learn. Yeah, there we go. Oh, yeah. I was looking at this and I'm like, but I should need way more. That's because the ceiling. I should talk that out more. That's because it's more absorptive up here. And if we look at the walls, they're 0.06, it's 0.15. 100% makes sense now. What I said last. So need a coefficient. We do equal. That's what we need. It's our goal minus what's existing for the east wall. This should be quite a bit more. Copy that across. Now we need to take, where do we do it? Area first. Area times not total area. Area for the east wall. Much better. And let's absolute that. There we go. So we need almost 1,000 Sabins. So if we can look at this east wall. We have about 1550 that we can cover unless we want to cover the Mason CMU walls. Let's say we do some drapery. Let's use his example here, his banners. Let's just go 0.55 across there for sake. It's easier to manage. just for the example, so we know where everything's at. Can see and adjust. So if we fill that concrete with 1,550 in Sabins, and we go back down here, now we can see that we only need 182. So maybe it's 182. So we need about 360 more. That's about half. So if we take off, we're not going to put it over glass. Let's just take 400 out. We'll do 600 masonry, and then we'll do 1950 in drapery. And we're with it. Right there. We could bump that up. Remember, if you're within 0.1, that's noticeable. 0.4 is considerable. So we're within range. The issue is if we can't put it on the ceiling or the floor, and we need to add additional absorption to these places. And that's where the averages come in over here. So let's do average, go down, average. And these will return 0 because we don't have anything there, but we'll go ahead and copy it. Save the keystrokes. And from here on out, we're just going to repeat this same aspect. And then we're to a point that we can figure out what those areas are. Do those averages. If we want it, we could also add maxes in here. I've done that before, but that's outside the scope of what we're doing for this project. You could add max, and that gives you an idea of saying, okay, well, what's the maximum out of here, which is this 0.28, this 1400. Because if I want to control that, I'd rather have this lower and this below the goal rather than having this 2K higher. But if you wanted a brilliant room and you wanted your highs, your high-end frequencies to have a little bit more reverberation, a little bit more presence in the room, that could be good too. You just need to identify what those are in there when you're on the goal of your room. All right, let's do the north wall. I can look at what we did. So subtract out our goal, average absorption, and we're doing the north wall. 0.24. Across we go. No adding that curtain. Drop these rooms just on that one wall considerably. So we will do surface of north wall times what that coefficient is. Go ahead and F4 that. Cut it down. Copy that across. 3 down, 3 to go. Let's do west wall. Goal minus. Oops, wrong. Wrong goal. I'm always drawn to that 1.2. So coefficient goal of the west wall equals, let's do this again, minus west wall copy that across equals area of west wall F4 that times needed coefficient of west wall copy that across south wall equal. Absorption goal minus south wall absorption. Pretty low absorption. Copy across. Equals area of south wall. Absolute that times needed of west wall. Copy that across. Now we just got to do the floor and then we are good to go. Then all we need to do is present the data, what's needed in a single PDF, not just a PDF of this. Actually, I don't want. To be creative on what you can get on a PDF. 8.5 by 11 PDF to give to the good old client. So goal needed minus what we have on the floor, which is quite a bit because we've got seats. So we're already within range there. And in the high end, we can see we're taking out a little bit too much. And then times, I should have F4'd that. So I'll go ahead and times. We need to take out some absorption. Let's F4. And copy that across. And we have it. So we that 1,000 that we needed. So this is where you can look at. I need 1,000 here. I have 1,000 too much here, so I don't need to add anything to the west wall. And you can kind of see where you need to put that absorption, and you want to do it in big swatches. We did the example here. So what I don't want to see is a final PDF. This is not what I don't want to just see a PDF printed of the spreadsheet that you sent me. This is no good. The client's not going to understand this. So put in the examples. Pulling back through this. On that PDF, you want to have room dimensions. You want to have room dimensions over here that you put presented so they understand it. What the materials are. So if you just do an equal or a lookup or some way of presenting what your materials that you have in the space, what your calculated reverberation time for earring and Sabin, and you can use this, or you can look and present it the way Ermin does, of just the average of 500 to 1,000. Either way is fine, as long as we got a reverberation time. We don't need all of this aspect in here. Volume of the space, so we've got that. What your target is, and then your needed reduction, which is your total savings. That in there. From that, then they can figure it out. Or what your solution is. If you want to put panels in, you can put panels in also. Either those work, but room dimensions, materials, what those areas for the surfaces are, volume, RT60, Sabin, and airing, target RT60, and then what the needed reduction is. That's it. And you got it. So, congrats. You have made it through the reverberation time. And now you can apply that without having a model or drawings and start picking out. If you look at that example to kind of give you an idea presented here of what those materials are: medium curtains, suede, unpainted concrete block. And this gives you an idea of what that NRC is to put you on your way. Glass, carpet, thick acoustic tile, down absorbent banners. Give you an idea of what you need to look for based on what we're figuring out. Oh, still in a print view. on how much area we have, i.e. we're not going to put it over the windows. So if we have 600 more that we want, let's say we want to cover this masonry in there, and we needed another 1200. Probably wouldn't work. Or we can take out there. And then we can figure that out. We've got a 0.8 in that area, and we had 600. So we'd have about 480 sabins that we would do. So that wouldn't meet our requirement of soaking up this 900. It'd only be half of it. But it'd be better than nothing. So that's what we get to figure out later. All right. Thanks. And I don't know. I don't know how to end this. Make a happy little tree like Bob Ross, maybe. I don't know any Lil Wayne lyrics either. So I will sign off.